Error refers to the gap between what actually happened and what you had forecast would happen. There's a lot of different ways to summarize error. You can see that in this scenario with the manager forecasting project management software. Let's take a look. A manager's been using a certain technique to forecast demand for project management software at her store. Actual demand, okay, that would be here, and her corresponding projections. Okay, so I mean the forecasting's already been done. Those were the forecasts are listed here. Now, what is the first part of this scenario? What is the manager's forecast error for April? All right, well, first off, I just need to locate that on the table. No problem. April is right here. And then I need to remember that error in a certain time period, like April, is what actually happened in that time period minus what we had forecast would happen in the time period. So for our purposes to answer this question, what actually happened in April was 42. Apparently, project management software packages were demanded, minus the manager had forecast that there'd be 50, so 42 minus 50, we would say that in April there was an error of a -8. Okay, now, next part. What was the manager's forecast percent error for, now wait a minute, not April, but July. Oh, wait a minute, percent error. Oh, percent error is the error divided by the actual for a period. So what I need to do is calculate the error for, and I have to be careful, not April, but July, and then divide it by the actual for July. So the error for July would be the actual in July, this is at the bottom of the table, so it won't be hard to spot, 38, minus what she had forecast in July, okay, that's 45, and then divided by the actual in July, which is 45. So I did that, and it comes out to be a -0.18, like 421, or a little bit more intuitive, is just change it into a percent, a negative like 18.4%. We would say that in July, the percent error was negative 18.4%. Okay, now that was easy. Let's look at the third one. What is the mean error, the mean squared error, the mean absolute deviation, the mean absolute percent error, and the tracking signal for these 5 months of forecasting? Oh, all right, these two things were fast. This third part for the scenario, it's not going to be hard, but it's not going to be that fast because it's asking for, and that's what I meant, it's asking for several different expressions of the overall degree of error in her 5 months of forecast. Okay, now, in preparation for actually answering that part of the scenario, what would be the easiest thing to do or the most convenient thing to do is, you know, in this problem, previously, it was just asking about certain periods, so I just did the error calculations for that period. What would be easier in this case, now that I realize we're going to need all those sort of summary scores, is to create another column. Just calculate the error in each of the months, because then that's the data we'll be working on to calculate all those other things that were asked. Okay, so the error in March. The error in March would be 45 minus 45. Oh, she was right. I mean, perfectly accurate. Right, the error is 0. The error in April we already did, but we're going to fill it in here. That's -8. The error in May, 34 minus 45. Okay, that's an error of a -11. The error in June, 48 minus 40 is +8 or 8. Okay, fine. And then the error in July, we were already looking at that. That is 38 minus 45. The error itself is a -7. All right, now, why did I say that we need that? Because down here, one of the first things that's asked is mean error. And mean error is just the average of those. Okay, I'm going to write ME for short. Mean error, I would just add those numbers up. 0, minus 8, minus 11, plus 8, 8, minus 7, right? Divided by 5. I'm averaging these. All right, so the mean error here, what I get is a -3.6. when you average that new column that I created. Okay, so that's the first thing. Okay, that's that one done. What about, okay, next it asks for mean squared error. Mean squared error, or I will write MSE. Mean squared error is, let's average the square of each of these. So that's that's adding together, well, 0 squared is 0, but plus a -8 squared plus, whoops, that's a plus, a little sloppy of me, plus a -11 squared plus 8 squared plus a -7 squared divided by 5. Kind of more of a chunky number. I get 59.6, just the average of the squared of the error. Okay, that's that one. Remember, these are basically scores for the overall degree of accuracy. What was the next one that was asked for? The mean absolute deviation. Mean absolute deviation, very common score for accuracy, abbreviated MAD. That one's easy. That's where you just average the absolute values of the errors. So we don't bother with the minuses. You can just say 0 plus 8 plus 11 plus 8 plus 7 divided by 5. I get a MAD of 6.8. Okay. That is that one finished. What else? The mean absolute percent error. Okay. Abbreviated the MAPE, mean absolute percent error. Okay, well, mean, I'm going to average. Absolute, I'm going to ignore minus signs, but I need percent error. Whoops. I need to do some more scratch work for that one. Because here's the errors that we've been averaging, like one way or another, square, dropping the signs, whatever. What's the percent error in each case for each day? Well, for March, it's 0% because it was 0 error. For April, it would be -8, the actual error, divided by 42. The actual, I get -0.19, or, you know, -19%. For May, the error is -11 divided by, let me trace it over here, the actual is 34, so I get a -0.324 on my calculator. For June, the error is a +8 divided by, look up, the actual is 48, so I get a +0.167. And then for July, the error is a -7 divided by 38, -0.184. Now, these are the individual percent errors, right? Oh yeah, that looks familiar. -0.184, that was actually the answer to the second part. Okay, fine. Now, what I'm trying to do is calculate the MAPE, the mean absolute percent error. That means that what I'm going to want to average is, just ignore the signs, but I'm going to want to average together 0, 0.19, 0.324, 0.167, and 0.184. Add them up. Divide that by 5. What did I get? I got 0.173 was the result. Or, it's a lot more intuitive to state it as a percent. 17.3% was the mean absolute percent error. Okay, and then is that all of them? Did we do all of them at that point? No, no, no. It wants one other thing. It wants the tracking signal. The tracking signal. Tracking signal is calculated by taking the sum of the errors and dividing it by the MAD. Oh, and the good news is because of all the other work for this particular part of the scenario, we already have the MAD. But the tracking signal, which is a ratio, the numerator is just add up the errors. Don't average them or anything, just add them up. So I would go back, all the way back to our original scratch work, and I would just sum these up. Sum them up. I can actually do that down here. 0, -8, -11, +8, minus 7. That's all in the numerator. And the denominator is, I already have it here, the MAD 6.8. So that the tracking signal I get is a negative 2.65. Finally, let's check. I think that we have calculated everything that they asked for. Mean error, got it. Mean squared error, got it. Mean absolute deviation, got it. Mean absolute percent error, yes. And the tracking signal, negative 2.65.